Welcome to this module on security. Fine. Earlier, in the earlier modules, we have seen most of the things which are required in developing a web application. Fine. Developing web application very important for a distributed application, right. So, fine, we can develop a web application, we can what we have covered is all Java technologies. We have seen the servlets, we have seen the JSPs, fine, and we have seen the MVC architecture. Yes, various components which can be created, fine, we can create all kinds of components, but what is another what is important is security. Security is another very important aspect for any kind of a web application, any kind of application. It may be a web application, even for non-web applications, fine. Any enterprise application, security would be a very important thing. So, we will be talking about security in the next this and the subsequent module, fine. This module concentrates on the basic security related elements which are available in the Java itself, the Java API itself. And the next module will be covering more about web related security, security for the web. Okay. So, let us begin with looking at the various kinds of security components, the various concepts related to security, fine. So, let us start by looking at some security concepts here. So, okay, there are many things security would relate to. You would fine, that very okay. I will cover the very common terminologies which are used in security. Some of the things like, okay, there is something called a digital signature, we have something called digital certificate, fine. Oh, what are these terms? There is something called, oh, we have some document, right, very commonly with documents also, oh, that PDF is a digitally signed PDF, or you have digitally signed documents or digitally signed. So, various things can be digitally signed. As far as Java technology is concerned, oh, in Java technology, if we have to develop any Java based applications, yes, we have the basic element here is a class, but then once you have developed those class, a set of classes is what is forming an application. Fine. Our application is just not going to be a single class, you would have a set of applications, and those set of applications when we distribute in the form of a jar file, fine, and then okay. So, our element here is a jar file, right. So, there are things like, okay, oh, that jar, if it wants to be, you have some concept of signing a jar, digitally signing a jar file. So, what are all these terms? What do we mean by a digital signature? Fine. So, let us start with looking at those things, at those aspects. Okay. So, coming to the things, okay, what are the requirements here? Okay. Oh, what is the exact requirement here? The requirement is you got some application and then it needs to be determined that this application is something which has been distributed by a particular person or an organization. There is some identity, fine, which needs to be associated with a particular code, or in case of a document, right, there is a document and we say, oh, someone is digitally signing the document. The idea here is, oh, I have seen the document and I endorse it. That is what is exactly meant by digitally signing. So, I have seen this application, or this application is from me, I authenticate everything, I endorse this document, I endorse this application. That is your requirement. Now, how does this all work? How do we have a digitally signing where it is, you know, someone says, okay, this is something which is digitally signed, and I would and it is, you know, it is very authentic, that the other person should be believing that yes, this exactly signed by this person only, this entity. So, it is something which has been endorsed by a particular entity. Okay. So, to build all this kind of infrastructure, fine, what is required is something known as we have public key encryption system, fine. Oh, what is this public key encryption interface which we have, fine. So, let us see the components which are required in the public key interface. Okay, fine. Let us talk about, you know, if you have a very old, so let us talk a little about what is known by encryption and decryption. Okay, just a little bit. okay, and then we will come back to it will be more on encryption and decryption. So, in the earlier days, okay, for communication purpose, if there has to be some secret communication which has to take place, so that if anyone sees that message in transit, even if someone sees the message in transit, the one who's seeing it in transit, if he is not authorized, he shouldn't be able to make out what that message is. Fine. Only the recipient of the message, the target recipient of the message, is the one who should be able to figure out what that message is about. Okay. So, in the old days, there was this Caesar code, which was kind of a code which was used. Okay. Now, in a Caesar code, what's important was, okay, we have some person A. Let's say we have two person who wants to communicate. A wants to communicate with B. Okay. So, when A wants to communicate with B, what they have in common is they have some kind of a key. Oh, there is not one key, there is a key pair basically. We will see how that key pair happens. Okay. So, what was Caesar? Okay. For every letter which you have, add a particular value to it. So, add a particular amount of offset. For example, you will say, okay, oh, let me add 3. So, every letter which I have to put in my message, I will just add 3 letters to it and create the message. When I put this message across, okay, the recipient should be knowing, oh, that this has been encrypted using 3, and therefore, what I need to do is I need to subtract 3 from everywhere, fine, and then I will get the original message. So, we have encryption, fine, there is a job of encryption which is done by adding 3, and there is a job of decryption which is about subtracting 3 from it. Okay. So, here, oh, I mentioned there is a key pair here, right? Oh, how is it a key pair? Here we have a common algorithm being used by both. They both use an algorithm called add. It is about adding, fine. There is one key called +3 and the opposite key is -3. If you encode using 1, it is the other key which will be used for decoding. So, you encrypt and decrypt, fine. For encryption, if this is the key, the opposite key is used for decryption. Okay, here the thing is the algorithm is so simple that yes, if you know one of the keys, you can easily determine the other key. Okay. So, that is simple, and therefore, this kind of a encryption logic, fine. If someone knows the key, the other person, anyone can decode it, fine. If someone knows the key for encryption, they can easily determine what is the key for decryption. Okay. So, fine, such things would not work, but yes, the principle is the same. What we have is, we have got special algorithms which are again based on this kind of a key value pair, key pair concept. Key pair, yes, a key for encryption and a key for decryption. If you encrypt using one, it can be decrypted using its opposite key. So, you always have 2 keys, there is always a key pair, fine. So, what can always be done? So, a kind of a mechanism which was being developed and which is very common is something like this. Oh, I want to send a message, fine. It is not a simple algorithm like the add algorithm. We have much better and much complicated algorithms, complicated in the sense, yes, the the important aspect for these key value pair, the key pairs which are being generated here is, the algorithms are such that if you know one of the keys, you can't determine what is the other key. These are those kind of algorithms, fine. The common algorithms used, such the algorithms which are used here are the RSA, the DSA. These are the common algorithms which are used for encryption and decryption purpose, fine. Encryption, you may use encryption, decryption using RSA, using DSA. These are the very commonly used algorithms, and here the key value pairs, fine. The key pairs rather is being used here. The key pair mechanism is used here. So, what is important is, oh, you generate a key pair, you create a key pair which works for RSA or it works for DSA. Use that key pair, but the key pair which is generated is going to be such that yes, given one of the keys in this key pair, there's no, it's not going to be a very, it's not going to be easy. It's going to take lots and lots of computing years in order to determine the opposite key. Okay. So, that is the security aspect in this, fine. It is just based on the, it is relying on this fact that yes, even if someone knows this key, fine, one of the keys, to determine the opposite key, okay, it would take lots of years for someone to be actually able to decrypt it, fine, to be able to find out what that opposite key is. So, that is what is giving security to this kind of a key pair. Okay. So, what we have here is, yes, the mechanism which is now getting adopted is something like this. If A wants to send something to B, or A wants to publish anything, fine. Okay, what he can always do is he can say, let me encrypt using my algorithm. So, everyone in this kind of a scenario, what is happening is every participant has a key pair, and in this key pair, because it is a pair of keys, one of the keys is designated as a public key, the other key would be designated as a private key, fine. So, once we have this public key and private key, that is our key pair. Now, the idea of public key and private key is, the private key is the one which is only known with the entity, the person who is going to be using that for his purpose, for sending purpose or encryption purpose, fine. And the public key is the one which is known to all the people, fine. Now, if you want to send anything, fine, if I want to send anything to B, from A to B, fine, we understand everyone has a public key and a private key. So, the public key, if A wants to send to B, what he can always do is he can use his private key, encode it, fine, and the public key is known to B, B can always decode it. But then, fine, but then something in transit, fine, anyone who gets the things in transit, they know this is from A, and they can always use the public key and get hold of it. Now, what can always be done is, okay, I want to send something to B, let me use his public key, I am sending to B. If I use the public key of B, if the recipient is B, fine, if I am using public key of B, B has his private key, which can, that is the only thing which can decode it. Okay, so, this thing works. So, you encode using the public key of the recipient, that is one aspect, but then to improve upon it, one more aspect was there, okay, then yes, if A is sending anything to B, how is B sure that it has been created by A only? Fine, anyone could have posed as A and sent a message to B by using the public key of B. So, in order to have this kind of a integrity that yes, this message comes from A only and no one else, we have two levels of encryption. What should be done if A wants to send a message to B is, A would use his public key, his private key to encode first whatever is the cipher text which comes out by encryption, that would again be encoded using the public key of B. Now, when anything reaches to B, what B will do, okay, this is supposed to be coming from A. So, let me first, anyway, I will have to first use my private key to get to the first level, and whatever is the output of the decryption using the private key of B, B then says, okay, if this is from A, fine, he applies the public key of A, because it was encoded using the private key of A, okay, that would turn out to be the correct message. And here, because the things which he has got has been obtained by applying the public key of A, B is sure this is message from A only. No one else could have encoded using the private key of A. Private key is something which is of A is with A. So, this is where we have a mechanism which works fine. So, this is one aspect. So, this is encryption, decryption, how things should work. Okay. So, we have algorithms for encryption and decryption. So, this is one aspect, this is good. Okay. So, in this system, yes, everyone should have a key pair, fine. Now, this key pair, there are other uses of this. Now, you have something which is actually a document. You have a document and it is only about this document, I have seen this document and I endorse this document. but then after someone has endorsed the document, someone makes changes in that, and I would like a mechanism which says, okay, this is something which was endorsed by A, and after that there has been no changes. Fine, the integrity of the document, fine, as it was when A has seen the document. So, how do we achieve this? So, for this there are another kind of algorithms which are available. We have these algorithms for hashing. Okay. So, what we do is we do not encrypt the entire document, fine. What okay, if A wants to say, okay, I want to, it is about signing a document, fine. What I am talking now about, is about signing a document. So, if A wants to sign a document, what he would be doing is, he would have his, he would take the document and then take a one-way hash of the document. It would be very, it would be very costly to encrypt the entire document itself, fine. And so, what is being done is, yes, we take a fingerprint, one-way hash, we have one-way hash algorithms. So, there are lots of one-way hash algorithms, and we have this one-way hash algorithms called SHA1, fine, and fine, there are many MD5, SHA256. Okay. There are lots of these SHA and MD5, those kind of one-way hashing algorithms. The idea of a one-way hash algorithm is, yes, you have a document, create a one-way hash, fine. If there is any change taking place in the document, okay, the source, then the one-way hash generated for that change document will be completely different from the earlier one, fine. And given the one-way hash values, from the one-way hash, it is impossible to regenerate the whole thing. It is just a fingerprint of this. It is not the entire document itself. So, one-way hash are these kind of algorithms, fine. They just generate one hash value, fine. It is okay, and a certain number of bits would be there. We will have, for example, if we have MD5, fine, it would be just 16 bytes, fine, 128 bit MD5. If you have SHA1, it would be 160 bits, fine. We have SHA256, it implies, yes, it is going to be 256 bits. So, each of those kinds of algorithms are, for hashing algorithms, are available. Okay. So, fine. So, we have these kind of hashing algorithms. Now, the role of these hashing algorithms for digital signing. What is their role? Okay. Someone wants to digitally sign a document, fine. What he would do is, he will take the one-way hash of the document, fine, using any one of those algorithms. Maybe he says, I want to use SHA1, fine, use SHA1 for generating the one-way hash, and after the one-way hash is generated, he will then apply the private key, fine. In this case, let us assume A is a signer. So, the private key of A is applied on the one-way hash. So, one-way hash is a very small, it is just a fingerprint, right, but on that he is applying the encryption, fine. When he generates an encryption of that, fine, it would again be a smaller thing, it will not be a huge thing. So, encryption of the one-way hash which has been generated for the document, fine, this value which is generated is then stored along with the document. So, this is the document which is digitally signed. You can see here that how the integrity checks can be applied here, fine. This is something which can always be verified. If there is any change which is done in the document, its one-way hash would change. Now, see, when this document is seen by anyone, and if he wants to verify, is it actually being signed, is it digitally signed by this, and is that digital signature of that particular person, is it being endorsed by that person, and whether it has been altered or not, or after that person had signed, if something has been altered in the document, that should be fine, the integrity check that should be carried out. So, for that, the mechanism which is applied would be, okay, the one who wants to verify can always do this. What he does is, he takes the one-way hash of the entire algorithm, again the same hashing algorithm should be used, okay, and then what he does is, yes, he will apply the public key of, he will apply the sorry, he has the digital signature also, which was nothing but the applying the private key on the one-way hash. fine. So, that value which is available, he will apply the public key of the signer. When he applies the public key of the signer, he should be getting the one-way hash value, fine, because it was the one-way hash which was on which we had applied the private key of A. So, applying the public key of A on that would again give me back the one-way hash. So, we just need to verify that one-way hash which is obtained by applying it using the public key on A on the signature which has been mentioned. If that matches the one-way hash of the entire document, then yes, this document did not change, and yes, it has been endorsed by this person only. Fine. So, this is what exactly is digital signing about. Digital signing means, okay, we have two algorithms, one is hashing and encryption, fine, encryption of the hashed value and keeping that along with the document, fine. So, yes, we have concepts of signing a jar file. Okay. Java gives us signing of jar file, and Java also gives us mechanism of verifying the jar file. Okay, jar files are fine, they are one thing, but then okay, we can have jar files, but one thing we have all been talking about is we have the one-way hash. Now, if you want let us say we want in the Java itself, fine, suppose from within your Java application you would like to generate a one-way hash. How to have one-way hash? So, for that if you want to use such thing, we have this java.security package having a class called message digest, fine. The message digest is a very simple class, fine. It can very easily be used. You have a static method here in order to create an object of message digest. What you need to specify, fine, is you have the get instance method where you need to specify a static method get instance where you need to specify which you select the algorithm for which you want the one-way hash. Okay. So, you can say message digest dot get instance and you pass your algorithm as a string. So, algorithm could be MD5, SHA1, SHA256, any of the supported algorithms for one-way hash. Once you get this object of message digest, what you need to do is in this message digest initially it is blank. What you need to do is you need to just keep on updating with all the bytes from your document, whatever, maybe it is a jar file, okay, the entire jar file, the contents of the jar file. In case of a jar file, actually each and every individual class files, every individual file, for each and every individual file, it would create a separate one-way hash and digital signature for that. Encryption on that would be done, and stored for every file a separate value would be stored. So, that integrity for each and every individual file can be verified. Okay. So, every individual file within a jar, the integrity can be verified. Okay. There is a meta-NF folder where those files will get created which contain the digital signatures, fine, and the associated information which can be useful for verifying whether this jar has been digitally signed or not, and if any of the classes there has changed, any of the files rather, it is not only class which you have in your jar file, you can have other kinds of things also, but yes, mainly it would be the class files. So, integrity check fine and signature related to a jar file that can be there, but we have this message digest class, and what message digest class has is a method called update. You push in those bytes for anything and generate a one-way hash for it. How do you get? Okay, just keep on calling the update method, fine, and then fine, keep on calling update method. In update you can give a single byte, you can give a byte array, fine, a segment of a byte array. So, that kind of update method available on object of message digest, fine, the object which has been created by specifying a particular algorithm. So, for that algorithm you have message digest, and then when you want to know the hash, once you have pushed in all, you updated the message digest object with all the bytes, okay, you can generate the one-way hash for all those set of bytes which have been pushed in by using a method called digest. The digest would return a byte array. So, that byte array is nothing but the that byte array, the size of that byte array would depend on what algorithm you have selected, fine. So, yes, according to the number of bits that one-way hash should be. So, if it is 128 bit, yes, you will get only 16 bytes. If it is at 160 bits, which is for SHA1, you will get 20 bytes, fine. So, accordingly you will have a one-way you will have a byte array generated with the digest method, fine. So, that is something if you could easily try out getting one-way hash for anything, fine. So, coming back to the things like we have the concept of digitally signing. So, what is fine? So, it is understood that yes, what is meant by digitally signing? Digitally signing anything involves use of taking the one-way hashes and then applying encryption on it. Fine. Now, here what we have here is in Java, as part of the JDK, there are easy tools available for these kind of things. Fine. So, some of the things which are needed here for security, one thing, some mechanism to create key pairs. Fine. How do I create a key pair? Fine. So, for creating a key pair, we have a tool called key tool. So, we have the key tool where we can say minus generate key, have a alias. So, you can say minus alias, fine. You can even specify which key algorithm to use, okay, and then the key pair can be generated. Public key, private key, that kind of a key pair can be generated, but where do we keep this key pair? The key pairs are stored in something called a Keystore. So, we got Keystore files. There are files which are Keystore. There are types of Keystores. The kind of Keystore which is normally supported by Java would be JKS, that is known as Java Keystore. JKS stands for Java Keystore. So, we can create JKS, the Keystore files which are of the type JKS. Fine. So, this can be created by using the key tool. In key tool, we can manage what can be managed in a key tool. In a key tool, you can manage key pairs. So, you what we call as keys, there are keys which are being created. So, one kind of entries which we have, a key store can have several kind of entries. So, one of the kind of entries is the key entries, and the other common kind of entries which we have in a key store are the certificate entries. Oh, what is this certificate? Oh, certificate, fine. You say this particular thing, you are trying to endorse something, but then how is it sure that this is your public key? You distribute your public key, but how can someone say this is your public key? So, therefore, just creating a public key anywhere and trying to use it is not the things. We have got authorities who actually authorize and give us the public keys, and they will authorize and say, okay, I endorse that this is the public key of this. Fine. So, we have these authorizing agencies, what we call as CAs, the certifying authorities. So, there are lots of certifying authorities, like we have Thought, Entrust, and so many, there is a number of such authorizing agencies. Fine. So, we have this CAs. Fine. Okay. Fine. So, now what we have here is the CAs would actually create a key, would actually what they can do is you can give a public key, you give your external, you will send your all your information, so that they can verify that this exactly is yourself only. Fine, your information needs to be authenticated. So, fine. So, give all such information and then they can issue a certificate to you. So, what is done for issuing that certificate? The public keys. Now, in this again, each of those certifying authorities also have their own key pairs. They have the public key, private key. Their private keys have to be really secure. So, it is their thing. They will be maintaining their private keys very securely. Fine. And then what they do is, yes, they use this private key on your certificate. So, they pick up all your information which is needed in your certificate. Fine. And then so, like what is the organization for which you work, and fine, organization unit, which country you belong to, fine, all that, your name, everything. So, all such information plus your public key. Your public key is then going to be part of a certificate. So, all this is going to be, what they do is they sign this. Signing means they do a one-way hash of this and then apply their private key, and what is then generated is actually known as a certificate. So, we have these kind of certificate entries which go in a Keystore. So, Keystore has two kinds of entries. There are key entries and certificate entries, and we have this tool called the key tool, which can be used for actually managing a Keystore, the entries in the Keystore. Fine. For more information, to try out something from Java, you have a class called Keystore, which can be used for managing all kinds of entries within our Keystore. Fine. So, you can refer to the API java.security package. There is a class called Keystore that can be used for managing entries in our Keystore. fine, and then there is yet another tool, fine. Once you have a key store in which you got your key, fine, if you have your key entry, fine, you in a key store, what you will normally be managing, or you will be managing your own key entry, and you will be managing the certificate entries for others, because yes, you would like to verify anything received from others. So, all those people from where you receive something which is secure, fine, you should be having their public keys, and because these public keys are again signed by the certifying authorities, you should be having public keys of all the certifying authorities, and that is also being managed in your key store. So, we have separate key store actually when we have JDK, or even when you use any of those tools like, okay, this is also very commonly used by browsers. Even browsers manage the public keys of the certifying authorities. So, certifying authorities, their public keys are managed in order to verify that the certificate is correct, fine. So, we have this kind of a tool for now. So, that is one part. So, key store, fine, key tool is something which can be used for managing key store. Fine. There is a file called CA certs which is available within JRE lib security. So, the JRE lib security, that is a folder where we have a CA certs, and this contains the public this contains the certificates for the certifying authorities, self signed certificates for all the certifying authorities. So, that is something which would be useful, and then we have another tool called the jar signer. A jar signer is something which is used for signing a jar file, fine. So, if you have a jar file, it can then be signed using the jar signer command. The jar signer command is also used for verifying that this jar which I have received is actually signed by, is the integrity of that jar file can be verified, and whether it has been signed by a particular person or not, fine. So, we have these two important tools available. There is a key tool and there is a jar signer, fine. Jar signer for verification, key tool for creating the generating key pairs, fine. Managing key store, key tool can be used for managing a key store. It also gives us the ability to generate key pairs. It has various kinds of commands, fine. So, that can be used for managing the key store, and from Java application there is a class called Keystore which can also be used for managing a key store, fine. So, that is something which you should be reviewing, fine. And yes, so that is what we have in this module. In the next module, we will be looking at the security for a web application, fine. That is it from me. Thank you. Thank you. Thank you. Thank you. Thank you.